Friends, before we dive into today's story, I'd love for you to subscribe to the channel, hit the like button, and share your thoughts in the comments below. It won't take you more than a second, but it means the world to me and helps this channel grow. Your support keeps the stories coming, so don't miss out. Subscribe now and join our little storytelling family. Now, let's step into today's tale. Space is an infinite expanse surrounding our planet and stretching into the farthest corners of the universe. It is the realm of stars, galaxies, nebulae, and black holes, a place full of mysteries and wonders that humanity has been trying to understand since ancient times. Space has always fascinated both scientists and the general public. But why does this topic capture people's imagination so deeply? First and foremost, because space holds countless mysteries and endless possibilities for new discoveries. According to the International Space Agency, more than 50 successful space missions have been launched in the past 5 years alone, allowing us to learn more about our universe. Scientists around the world are working tirelessly to uncover its secrets, and each year brings new and astonishing revelations. For example, in 2020, astronomers discovered a potentially habitable planet only 11 light years away from Earth. Such discoveries give hope that one day we might find extraterrestrial life and better understand our place in the cosmos. Space excites the imagination and inspires humanity to reach new heights. It's no wonder that it remains one of the most popular topics in both science and popular culture. The question of where exactly space begins has no single, definitive answer. One of the most widely accepted definitions of the boundary between Earth's atmosphere and outer space is the so-called Kármán line, located about 100 kilometers, 62 miles, above the planet's surface. It is believed that beyond this altitude, the atmosphere becomes so thin that aerodynamic flight is no longer possible, marking the beginning of outer space. However, some scientists argue that space actually begins higher than the Kármán line. For instance, the International Aviation Federation (FAI) defines the boundary at 100 kilometers, while NASA and the US Air Force place it at around 80 kilometers, 50 miles. These differences exist because the transition from atmosphere to space happens gradually, making it difficult to determine an exact limit. Nevertheless, most experts agree that space begins where Earth's atmosphere ends, roughly 100 kilometers above the planet. Space is an incredibly vast and diverse expanse, which can be roughly divided into several zones. The closest region to us is interplanetary space, which includes the area between the planets of the solar system. This zone contains the planets themselves, their moons, as well as asteroids and comets. Interplanetary space stretches from the Sun to the very edges of our solar system, a boundary defined by the orbit of its most distant planet, Neptune. Beyond that lies interstellar space, the vast region between stars within our galaxy. This space is filled with rarefied gas, cosmic dust, and high-energy radiation known as cosmic rays. Here, distances are so immense that they are measured in light years. The nearest star to us, Proxima Centauri, is located about 4 light years from the Sun. Interstellar space extends all the way to the borders of our Milky Way galaxy, which spans roughly 100,000 light-years across. Beyond, the Milky Way lies intergalactic space, the immense expanse that separates our galaxy from others. This is the largest and least explored region of the universe, where galaxies gather into clusters and superclusters, forming the grand, web-like structure of the cosmic landscape. When we gaze into the cosmos, we see planets, stars, and galaxies, all made of what scientists call normal or baryonic matter. This type of matter includes all known chemical elements, from hydrogen and helium to heavier ones like carbon, oxygen, and iron. It forms every familiar object and structure in the universe. Yet, despite being the substance of everything we can see, normal matter makes up only about 5% of the total mass and energy of the cosmos. The remaining 95% consists of the mysterious dark matter and dark energy, whose true nature remains one of the greatest enigmas of modern science. Dark matter is one of the biggest puzzles in astrophysics. Its existence was first proposed to explain certain anomalies in the motion of galaxies and galaxy clusters. Observations show that the visible mass of galaxies isn't enough to hold them together by gravity alone. They should simply fly apart. To explain this, scientists assume the presence of an invisible form of matter, creating additional gravitational pull that binds galaxies in place. Although the true nature of dark matter is still unknown, several hypotheses exist, including the possibility of new elementary particles, weakly interacting massive particles, axions, or sterile neutrinos. According to current estimates, dark matter makes up about 27% of the total mass and energy of the universe, more than 5 times the amount of normal matter. Even more astonishing, however, is another component, the mysterious and elusive dark energy. Its existence was postulated to explain the accelerating expansion of the universe. Discovered in the late 20th century through the observation of supernova. Dark energy behaves like a kind of anti-gravity, forcing galaxies to move away from each other faster and faster. The true physical nature of this mysterious force remains unknown, but some theories link it to the energy of the vacuum or to dynamic fields similar to the Higgs field. Dark energy is the dominant component of the cosmos, accounting for about 68% of the total mass and energy of the universe. It is dark energy that determines the future fate of our world, and understanding its nature is one of the most ambitious challenges in modern science. The 5 most unusual objects in Space One, the coldest place in the universe in the vastness of space. Where temperatures usually hover close to absolute zero, there exists an object that holds the record for being the coldest of all. It is the Boomerang Nebula, located in the constellation Centaurus, about 5,000 light-years from Earth. Temperature inside this nebula drops to just 272, making it the coldest known place in the entire universe. The gas in the Boomerang Nebula expands at incredible speed, causing this extreme cooling effect. 2. The hottest place in the universe when it comes to heat, the undisputed leader, is the center of our Milky Way galaxy. There lies the supermassive black hole Sagittarius A*, surrounded by swirling disks of incandescent gas. The temperature of this gas can reach 18 million kelvins, which is thousands of times hotter than the surface of the Sun. Such extreme conditions are caused by the intense radiation emitted as matter falls into the black hole, heating the surrounding gas to unimaginable levels. 3. The oldest star in the universe, the oldest known star, is HD 140,283, unofficially nicknamed Methuselah after the long-lived biblical figure. It is located in the constellation Libra, about 190 light-years away from us. This ancient star is estimated to be around 14 billion years old, making it almost as old as the universe itself. Methuselah belongs to the first generation of stars that formed soon after the Big Bang, despite its remarkable age. It still shines brightly thanks to its large mass and high surface temperature. 4. The largest structure in the universe, the largest known structure in the cosmos, is the Laniakea supercluster, a name that comes from the Hawaiian language, meaning immeasurable heavens. This enormous cosmic complex includes our own Milky Way galaxy and roughly 100,000 other galaxies, spread across an area about 500 million light-years wide. Our galaxy is located on the very edge of this enormous cluster, in a region known as the local void, a relatively empty space between superclusters. The largest source of water in space. The biggest reservoir of water in the universe is a massive cloud of water vapor discovered in a galaxy about 12 billion light-years away from Earth. This cloud contains 140 trillion times more water than all of Earth's oceans combined. The water gas 392 F. Such an enormous concentration of water vapor is likely connected to intense star formation within that galaxy, which releases huge amounts of water molecules from interstellar dust. The universe, a realm of mystery and wonder. Space is an infinite expanse filled with mysteries and astonishing objects. We've only looked at a few examples, yet even they are enough to grasp how diverse and extraordinary our universe truly is. From the coldest nebulae to the blazing cores of galaxies. From the oldest stars to vast superclusters, the cosmos captivates the imagination with its immense scale and contrasts. But what else do we know about space? Here are a few additional facts that help us better understand the structure of the universe. There is no sound in space, because sound waves need a medium, such as air or water, to travel through. In the vacuum of space, sound simply cannot propagate. The most common element in the universe is hydrogen, accounting for about 75% of all ordinary matter. Black holes aren't T-holes in the literal sense. They are regions of space with gravity so strong that not even light can escape them. The solar system moves through space at about 220 kilometers per second, 136 miles per second, relative to the center of our galaxy. According to modern estimates, the universe contains around 200 billion galaxies, each hosting hundreds of billions of stars. By studying the cosmos, we gain a deeper understanding of our place in it and realize just how vast and complex the surrounding universe is. Every new discovery brings us closer to unraveling its mysteries, yet each answer leads to even more questions. Space will never cease to amaze us with its beauty, complexity, and scale. And one curious fact, you can't cry in space. Without gravity, tears don't roll down your cheeks. Instead, they form little floating spheres that hover right in front of your eyes. On Mars, there is a mountain called Olympus Mons, the tallest known volcano in the solar system. Due to the expansion of the universe, galaxies are moving away from us faster than the speed of light. However, this does not violate Einstein's theory of relativity, because it is space itself that is expanding, not the galaxies moving through it. If you were to fall into a black hole, in theory, you could see your own back, as the immense gravity bends light around it. On Jupiter and Saturn, it rains diamonds. In the dense atmospheres of these gas giants, carbon condenses into crystals under extreme pressure, forming literal diamond rain. The sound from the loudest known explosion in the universe reached Earth 50 million years. After it happened, it was the explosion of a supernova recorded in 2003. Here are more fascinating facts about space. If you've spent at least 20 minutes in space, you are officially considered an astronaut. If you were to detonate a nuclear bomb in space, you wouldn't hear anything because sound cannot travel in a vacuum. You could fit more than 1 million Earths inside the Sun. The most powerful telescope in the world can detect a bee on the moon. It's the Chinese Fast Radio Telescope, which has a 500-meter, 1,640-foot diameter. The first human in space was the Soviet cosmonaut Yuri Gagarin. His historic flight took place on April 12, 1961. Aboard the spacecraft Vostok 1, Gagarin completed one orbit around Earth in 108 minutes, successfully landing in the Saratov region. Before liftoff, he hit the nail, the nice boyahali, let's go. A word that became a symbol of the dawn of the space age. Gagarin was chosen from over 3,000 candidates, and only 20 made it to the final selection. He was the best among them. After his triumphant flight, Yuri Gagarin became a global hero, visiting dozens of countries and being welcomed everywhere as a symbol of human achievement. Black holes. Fascinating facts: black holes aren't entirely black. They can emit faint light due to Hawking radiation, a quantum effect near the event horizon. The largest known black hole has a mass of about 66 billion suns and lies at the center of a supermassive galaxy. If a person were to fall into a black hole, they would appear to stretch infinitely and never fully disappear beyond the event horizon from an outside observer's perspective due to time dilation. Despite their name, black holes aren't cosmic vacuum cleaners. To fall into one, an object must cross the event horizon, which requires getting extremely close. Theoretically, rotating black holes could act as portals to other universes. According to certain solutions of Einstein's equations, though this remains purely theoretical due to the extreme conditions. Facts about space exploration. Throughout history, over 550 people from nearly 40 countries have traveled to space. In total, humanity has spent over 140 years in space cumulatively. The first woman in space was Soviet cosmonaut Eva Wolf-Loin-Jun, a mystery days. The most expensive project in the history of space exploration is the International Space Station ISS. Its total cost is estimated to exceed $150 billion. The longest space mission ever lasted 437 days and 18 hours, a record set by Russian cosmonaut Valery Polyakov in 1995 aboard the Mir space station. Astronauts on the International Space Station ISS witness 16 sunrises and sunsets every day, since the station completes one orbit around Earth every 92 minutes. Due to the lack of gravity, astronauts sleep in special sleeping bags attached to the walls of the spacecraft. Otherwise, they would simply float in their sleep. The Sun is a gigantic star, 109 times larger than Earth in diameter. If the Sun were the size of a melon, the Earth would be as small as a pea beside it. In our solar system, there's a dwarf planet Pluto, which is smaller than our Moon. It used to be classified as a full-fledged planet, but in 2006, its status was redefined. On the Moon, there are regions called seas, such as the Sea of Tranquility or the Sea of Rains, but these are not real seas. They are vast dark plains made of solidified basaltic lava. Since there's no air in space, talking is impossible. Astronauts communicate via radio. On the ISS, the only sound you hear is the hum of equipment operating in the station. Space Myth's myth, the Big Bang, was an explosion in empty space. Fact, in reality, the Big Bang was the rapid expansion of spacetime itself from a singularity. Before it, there was no space and no time. Myth, blood boils in space. Fact, blood does not boil in space because it is under pressure inside the body. However, vacuum exposure can cause swelling of tissues and loss of consciousness. Myth, asteroids are a major threat to Earth. Fact, most asteroids are too small to be dangerous. Only very large ones, over 1 kilometer in size, could cause a global catastrophe, and such impacts are extremely rare. Myth, the planet Nibiru will collide with Earth. Fact, the planet Nibiru doesn't exist. It is a fictional creation from conspiracy theories. Astronomers have found no evidence of its presence anywhere near Earth. Myth, the Sun is yellow. Fact, the Sun is actually white. It appears yellow only because of light scattering in Earth's atmosphere. In space, it looks pure white. Interesting facts about space. Our Moon is slowly moving away from Earth at a rate of about 4 centimeters per year. This also causes Earth's rotation period to slow down by about 2 milliseconds per day. Every year, about 40 new stars are born in our galaxy alone. It is hard to imagine how many form throughout the entire universe. The universe has no known boundaries. While it seems everyone knows this phrase, the truth is, no one actually knows whether the universe is truly infinite or just unimaginably vast. Our solar system is, frankly, terribly boring. When you think about our neighbors, they're nothing more than dull gas giants and chunks of rock. Between us and the nearest star lie vast stretches of empty space. And yet, out there in other systems, the universe is full of bizarre and wondrous things. One of the most fascinating discoveries in the cosmos is a giant gas bubble about 200 million light-years across, located some 12 billion light-years away from us. This incredible structure formed just 1 billion years after the Big Bang. The Sun is about 110 times larger than Earth, even surpassing Jupiter, the giant of our solar system. But when compared to other stars in the universe, our Sun is like a tiny spark in a cosmic nursery. That is how small it is. Now imagine a star 1,500 times larger than the Sun, if we were to place the entire solar system next to it. It wouldn't even fill a single pixel on its surface. This colossal star is called VY Canis Majoris, meaning the Great Dog, with a diameter of around 3 billion kilometers. How and why it grew to such monstrous proportions remains a mystery. Science fiction writers once imagined about 5 types of planets, but reality has proven far more diverse. Scientists have already discovered around 700 types of planets, one of the most extraordinary being the diamond planet. And yes, it's literally made of diamond. Carbon, as we know, only needs the right pressure and temperature to crystallize. In this case, the conditions were just perfect. The entire planet solidified into a cosmic jewel. A black hole, surprisingly, is one of the brightest objects in the universe. Inside a black hole, gravity is so immense that not even light can escape. Logically, that should make them invisible, but that's not quite the case. As a black hole spins, it consumes not only stars but also massive clouds of gas, which begin to glow intensely as they spiral inward. When meteors fall into black holes, they too ignite, burning brightly from their extreme acceleration. The light of our sun that we see every day is about 30,000 years old. The energy we receive today was created in the sun's core roughly 30,000 years ago. That's how long it takes for photons to travel from the center to the surface. Once they escape, however, it takes them only 8 minutes to reach Earth. We are constantly hurtling through space at incredible speeds, about 530 kilometers per second. Within our galaxy, Earth travels at roughly 230 km per second, while the Milky Way itself races through the universe at 300 km per second. Every single day, around 10 tons of cosmic dust fall onto Earth. And across the vastness of the universe, there are over 100 billion galaxies, each filled with its own mysteries, stars, and worlds yet to be discovered. There is a chance that we are not alone. The average density of Saturn is twice less than that of water. This means that if you could somehow place the planet in a giant glass of water, it would actually float on the surface. Of course, you can only test this theory if you manage to find a glass big enough. The Sun loses about 1 billion kilograms every second. This happens because of the solar wind, a stream of charged particles constantly moving away from the surface of the star in all directions. If you tried to reach the nearest star after the Sun, Proxima Centauri, by car, driving at 96 kilometers per hour, it would take around 50 million years to get there. Even the Moon experiences its own kind of earthquakes, called moonquakes. However, compared to the ones on Earth, they are incredibly weak. There are about 3,000 moonquakes every year, but their total energy would only be enough to power a small fireworks show. The strongest magnet in the entire universe is considered to be a neutron star. Its magnetic field is 1 billion times stronger than the magnetic field of our planet. Interestingly, in our solar system, there's an object that is very similar to Earth. It's called Titan, one of Saturn's moons. It arrive, seas, volcanoes, a dense atmosphere, just like our own planet. Amazangli. The distance between Titan and Saturn is almost the same as the distance between the Earth and the Sun, even the ratio of their masses is similar to that between the Earth and the Sun. However, intelligent life on Titan is unlikely. Its seas and lakes are composed mainly of liquid methane and propane. But if the most recent discoveries are confirmed, scientists believe that primitive life forms might still exist there. Beneath Titan's surface lies an ocean made of 90% water. The remaining 10% are complex hydrocarbons, which could potentially give rise to the simplest bacterial life forms. If Earth orbited the Sun in the opposite direction, a year would be 2 days shorter. A total lunar eclipse lasts about 100 minutes, while a total solar eclipse lasts no longer than 7.5 minutes. Isaac Newton was the first to describe the physical laws that govern the motion of artificial satellites. He published them in his legendary work, Mathematical Principles of Natural Philosophy, in the summer of 1887. Americans spent over $1 million trying to invent a pen that could write in space. Meanwhile, Russian astronauts simply used an ordinary pencil, and it worked perfectly fine in zero gravity. The universe itself moves at a speed of about 2 million kilometers per second. According to scientists, we are being pulled towards something called the Great Attractor, an enormous region of space filled with countless clusters of galaxies. It's one of the most powerful sources of gravitational pull in the known universe. The closest and most accessible region of outer space for exploration is near-Earth space. It was from this very region that humanity began its journey into the cosmos. Here, the first rockets were launched, and the first orbits of artificial satellites were established. Manned spaceflights and the direct spacewalks of astronauts have significantly expanded the possibilities for studying near-Earth space. Space exploration also includes the study of deep space and a number of new phenomena related to the effects of microgravity and other space factors on physical, chemical, and biological processes. But what is the physical nature of near-Earth space? The gases that form the upper layers of Earth's atmosphere are ionized by the sun's ultraviolet radiation, meaning they exist in a plasma state. This plasma interacts with Earth's magnetic field in such a way that the magnetic field exerts pressure upon it. As we move farther from Earth, the pressure of the plasma decreases more rapidly than the magnetic pressure. Because of this, Earth's plasma envelope can be divided into two main regions. The lower region, where plasma pressure exceeds magnetic pressure, is called the ionosphere. Interregion. Plasma behaves mostly like Norga, except that it has electrical conductivity. Above it lies the magnetosphere, where the magnetic pressure is stronger than the gas pressure of the plasma. Here, the behavior of plasma is controlled primarily by the magnetic field and differs drastically from that of ordinary gases. For this reason, unlike the ionosphere, which is considered part of Earth's upper atmosphere, the magnetosphere is classified as part of outer space. By its physical nature, near-Earth space, or near space, is essentially the magnetosphere. Within the magnetosphere, charged particles can be trapped by Earth's magnetic field, which acts as a natural magnetic trap. This process creates Earth's radiation belts. The magnetosphere is considered part of outer space because it interacts closely with distant cosmic objects, primarily with the Sun. The Sun's outer layer, called the corona, emits a continuous stream of plasma known as the solar wind. Near Earth, this solar wind interacts with our planet's magnetic field. For plasma, a strong magnetic field acts almost like a solid obstacle. It flows around it, much like a supersonic stream of gas flowing around an object. À sa résulte, standing forms choc front of Earth's magnetosphere, located about 14 Earth radii away, roughly 100,000 kilometers from the planet's surface. Behind this shock front, on the sunward side, the plasma that has passed through the wavefront moves in a chaotic, turbulent motion. The transitional turbulent region ends where the pressure of Earth's regular magnetic field exceeds the pressure of the turbulent plasma from the solar wind. This marks the outer boundary of the magnetosphere, known as the magnetopause, located about 10 Earth radii, roughly 60,000 kilometers, from Earth's center on the sunlit side. On the night side, the solar wind stretches the magnetosphere into a plasma tail, sometimes inaccurately referred to as a gas tail. When solar activity increases, for example, during solar flares, massive eruptions of solar material occur, ejecting separate blobs of plasma into space. When these plasma clouds travel toward Earth and collide with the magnetosphere, they cause it to compress temporarily and then expand again. This process produces geomagnetic storms, while some of the charged particles that penetrate deeper into the magnetosphere create the beautiful northern and southern lights and can also disrupt radio and even telegraph communications. The most energetic particles from these solar plasma ejections are detected as solar cosmic rays. However, they make up only a small fraction of the total cosmic ray flux in the universe. Now, let's move on to the solar system, where the nearest targets for space exploration, the moon and planets, are located. The space between planets is filled with an extremely low-density plasma carried by the solar wind. The way this plasma interacts with a planet depends on whether or not that planet has its own magnetic field. For instance, the magnetic fields of Jupiter and Saturn are much stronger than Earth's, making the magnetospheres of these gas giants far larger and more extensive than our own. On the other hand, Mars has a very weak magnetic field, hundreds of times weaker than Earth's, and can barely resist the incoming solar wind even near its surface. A prime example of a non-magnetic planet is Venus, which lacks a magnetosphere entirely. However, even in this case, the supersonic solar wind colliding with Venus's upper atmosphere creates a shock wave similar to what happens around magnetic planets. The natural satellites of the giant planets show great diversity as well. One of Jupiter's moons, Io, is the most volcanically active body in the entire solar system. Titan, Saturn's largest moon, possesses a dense atmosphere. Somewhat comparable to Earth's, the interaction between such moons and the surrounding plasma of their parent planets. Magnetospheres is also remarkably complex and fascinating. Saturn's rings, composed of rocky and icy fragments ranging from large boulders to fine dust particles, can be viewed as a giant cluster of miniature natural satellites orbiting the planet. Meanwhile, comets travel around the Sun in highly elongated orbits. Their nuclei are made up of rocks and dust particles frozen within icy blocks, but this ice is far from ordinary. It contains not only water, but also ammonia and methane, giving comets their mysterious and dynamic nature. The chemical composition of cometary ice is remarkably similar to that of the largest planet in our solar system, Jupiter. When a comet approaches the Sun, its ice partially evaporates, forming a giant gaseous tail. These comet tails always point away from the Sun, constantly pushed by the pressure of solar radiation and the solar wind. Our Sun is just one of countless stars that make up a vast stellar system, a galaxy. And this galaxy, in turn, is only one among billions of others scattered throughout the universe. Astronomers use the word galaxy both as a proper name referring to our own galaxy and as a common noun for all such systems. Our Milky Way galaxy contains approximately 150 to 200 billion stars. They are arranged in such a way that the galaxy appears as a flat disk, with a central bulge, a spherical region whose diameter is smaller than that of the disk itself. The Sun is located near the edge of this disk, almost in its plane of symmetry. That is why, when we look up at the night sky along the plane of the disk, we see a luminous band known as the Milky Way, a glowing path made up of countless stars belonging to our galactic disk. The word galaxy comes from the Greek galaktikos, meaning milky, and it literally refers to the Milky Way system. Astronomers have discovered that the stars of the galactic disk differ in physical and chemical properties from those in the central bulge. These two distinct stellar populations are referred to as the flat component and the spherical component of our galaxy. Within the disk, besides stars, there also exists interstellar gas and dust. Radio astronomy data show that the disk of our galaxy has a spiral structure, similar to what can be seen in images of other galaxies, such as the famous Andromeda Nebula. By studying stellar spectra, their motions and other physical properties, and comparing them with theoretical models, astronomers have developed a theory of stellar structure and evolution. According to this theory, the main source of stellar energy is nuclear fusion reactions occurring deep inside a star's core, where the temperature is thousands of times higher than on its surface. The field that studies nuclear reactions in space and the origin of chemical elements is known as nuclear astrophysics. At certain stages of their evolution, stars eject part of their material into space, enriching the interstellar gas. The most powerful of these ejections occur during stellar explosions, observed as the outbursts of supernova. The remnants of such explosions often become pulsars, neutron stars with a radius of about 10 kilometers. Possessing extremely strong magnetic fields that create intense, compact magnetospheres. It is believed that the magnetic field of the pulsar at the center of the Crab Nebula, a classic remnant of a supernova explosion, is about 1,010,000,000 times stronger than Earth's magnetic field. In binary star systems, neutron stars can manifest themselves as X-ray pulsars. Neutron stars are also associated with so-called bursters, galactic objects characterized by periodic, short bursts of X-ray and soft gamma radiation. In other cases, stellar explosions may result in the formation of black holes, objects whose matter collapses toward the center at speeds close to the speed of light. Due to the effects described by the general theory of relativity, the theory of gravitation, this matter appears to freeze during its fall, and no radiation can escape from within a black hole. At the same time, the matter surrounding a black hole forms what is known as an accretion disk, which, under certain conditions, emits X-rays as a result of the gravitational energy released by matter falling toward the black hole. During stellar explosions and in the vicinity of pulsars, individual plasma particles are accelerated to enormous energies. These particles contribute to the high-energy component of the interstellar gas cosmic rays. In terms of quantity, cosmic rays represent a very small fraction of interstellar matter but in terms of energy, they make up a significant portion. Cosmic rays are trapped within the galaxy by magnetic fields, and their pressure plays an important role in maintaining the structure of the galactic disk. When cosmic rays interact with atomic nuclei in Earth's atmosphere, they produce a large number of new nuclear particles. The study of cosmic rays near Earth's surface belongs to the field of nuclear physics. Instruments placed outside the atmosphere, however, provide information about primary cosmic rays, which is crucial for space research. Such are the structures and physical processes characteristic of our own galaxy. Other galaxies display a great diversity in shape. The number of stars they contain and the intensity of their electromagnetic radiation across different wavelength ranges. The origin of galaxies and the reasons why they differ in shape, size, and other physical properties remain among the most challenging problems in modern astronomy and cosmology. Moving to even grander scales, we enter realms about which very little is known. The study of the structure and evolution of the universe as a whole is the domain of cosmology. For this field, the latest advances in radio astronomy are of particular importance. Powerful sources of radio and light emissions have been discovered. Quasars in their spectra, the lines are greatly shifted toward the red end of the spectrum. This means they are extremely far away from us. The light from them has been traveling for billions of years. By observing quasars, astronomers have the opportunity to study the universe, the metagalaxy, at the early stages of its evolution. Where does the enormous energy emitted by quasars come from? This remains one of the most fascinating mysteries of modern science. Another important discovery was the detection of background radio frequency, radiation that uniformly fills the entire cosmos. This relic radiation is a remnant of the earliest epochs of the universe, allowing scientists to understand its state many billions of years ago. The current stage of space science is characterized by a tremendous increase in the flow of incoming information, whereas earlier astronomical instruments could only detect visible light. Today, data about the cosmos are obtained from across the entire electromagnetic spectrum. This means that studying the primary cosmic rays provides valuable information about physical processes in the interstellar medium. Scientists have managed to detect penetrating particles, neutrinos arriving from the Sun, in the future. It may be possible to detect and study neutrinos originating from the depths of outer space. The expansion of information channels is connected both to the deployment of observational equipment in space, extraterrestrial and balloon astronomy, as well as direct studies of the Moon and planets using instruments delivered to their surfaces and to the improvement of ground-based equipment. The importance of placing research instruments in space lies in the fact that nature has placed us at the bottom of an atmospheric ocean, which limits our ability to observe the universe, but at the same time protects us from many types of cosmic radiation. The atmosphere allows electromagnetic radiation to reach the Earth's surface only within to narrow frequency ranges, or so-called windows, one in the visible spectrum and the other in the radio range. Only by using instruments placed beyond the atmosphere has it become possible to detect X-rays, gamma rays, ultraviolet, and infrared radiation coming from space. The same applies to primary cosmic rays. Our universe was born billions of years ago. It encompasses all of existence, galaxies, stars, planets, everything that forms the vast cosmic expanse. Scientists estimate that there are hundreds of billions of galaxies, though none of them can be seen without a telescope. Moreover, each of these galaxies contains billions of stars, and the total number of stars in the universe reaches about 10 billion trillion. That means there are more stars in the cosmos than grains of sand on all the beaches of Earth. Let's get acquainted with our galaxy. In the evening, when the sun sets beyond the horizon, look up at the sky. Depending on how dark it is, you'll see clusters of stars, each one belonging to our own galaxy. The Milky Way. Across the night sky stretches a soft, glowing white stream. It isn't uniform. In some places it's denser, while in others it seems to split into branches. Parts of this great swirl stretch silently and majestically across the heavens. It's also been called the Path of the Gods or the Heavenly Road. The name Milky Way itself captures the imagination, almost poetic in its beauty. And indeed, its origin sounds like a myth. In ancient times, celestial objects were often named after Greek legends. According to one such myth, Hercules, the son of Zeus and a mortal woman, was placed at the breast of Zeus's sleeping wife, the goddess Hera. As he drank her milk, the child gained immortality. When Hera awoke and angrily pushed the infant away, her milk spilled across the heavens. Indeed, the pale band of the Milky Way looks like spilled milk, the combined glow of countless stars, blending into a luminous streak to the naked eye. The Milky Way revealed its secret only in 1610, the great scientist Galileo Galilei, looking through his telescope, discovered that the Milky Way is not a cloud at all, but an immense cluster of stars so numerous and close together that they appear as a faint, milky shimmer when viewed without instruments. The study of the Milky Way continued into the 18th century. One of its most active explorers during that time was William Herschel. His observations led to the conclusion that the Milky Way is a vast island universe of stars, and that our Sun is part of it. Herschel even drew a schematic diagram of his discovery, depicting the stellar system as a kind of millstone with an elongated, irregular shape. The Sun, he believed, lay within this great ring that surrounded our world. This was how scientists imagined our galaxy until the early 20th century. Only in the 1920s did Jacobus Kapteyn publish a more detailed model of the Milky Way, creating a representation remarkably close to what we know today. Now we understand that the Milky Way is a galaxy containing the solar system, Earth, and all the individual stars visible to the naked eye. The Milky Way belongs to the class of spiral galaxies. Though it is not an ordinary one, its structure is far more complex and majestic. As with many galaxies in the universe, the Milky Way has a central bar, a bright, elongated structure composed of some of the most luminous stars. This bar extends from the galactic center, crossing the galaxy through its middle. Unlike other spiral galaxies, the Milky Way's spiral arms do not originate directly from the core. Instead, they begin at the ends of this bar. At the center of the galaxy lies a brilliant nucleus made up of billions of stars. Its exact size is difficult to measure, but scientists estimate it stretches several thousand parsecs across. Many astronomers also believe that at the very heart of the Milky Way resides a supermassive black hole. Surrounding the Milky Way is a vast dark halo, enormous regions of non-luminous matter that contain dwarf galaxies and clusters of stars. The spiral arms rotate around the center, forming a massive disk. Because of this rotation, the Milky Way appears relatively flat when viewed from the side. Astronomers distinguish 5 main spiral arms: Cygnus, Centaurus, Sagittarius, Orion, and Perseus. Our solar system lies within the Orion arm, closer to its inner edge. The galaxy itself spans an estimated 200,000 light-years across. The largest neighboring galaxy is Andromeda, which is about twice the size of the Milky Way. Further away lies the Triangulum Galaxy, another spiral system. Surrounding these major galaxies are their satellite systems, dwarf galaxies, and stellar clusters. According to scientists, the Milky Way and Andromeda galaxy are moving toward each other and may eventually collide. Andromeda is currently approaching the Milky Way at a speed of roughly 120 kilometers per second. Whether the two galaxies will actually merge or simply pass by one another remains uncertain. Astronomers believe that similar galactic collisions have already occurred, perhaps as long as 10 billion years ago. But that topic deserves a discussion of its own. We rarely stop to think about the immense star that warms us, sustains life on Earth, and fills us with light, energy, and even endorphins. Yet our Sun, though not the farthest or the largest, remains one of the most mysterious celestial bodies to humanity. Every year, on May 3rd, astronomy enthusiasts around the world celebrate World Sun Day in honor of this event. Let us uncover a few of the Sun's secrets and explore some fascinating facts about this star from A to Z. The ancient Greek astronomer Aristarchus of Samos was the first to propose the revolutionary idea that the Earth revolves around the Sun. It takes the Sun a little more than 27 Earth days to complete one rotation around its axis. Interestingly, the layers of solar material at the equator rotate nearly 1/3 faster than those near the poles. Scientists estimate the age of the Sun to be approximately 4.6 billion years. Right now, the Sun is approximately in the middle of its life cycle. Its gravitational pull is about 28 times stronger than Earth's. If a human could somehow stand on the Sun, they would weigh 28 times more and be unable to move due to the immense gravity. About 90% of the Sun's volume consists of hydrogen, which will eventually be depleted over billions of years. When that happens, the Sun will begin to burn hydrogen in its outer layers, transforming into a red giant and engulfing Mercury, Venus, Earth, and Mars. If you could watch a sunset from Mars, it wouldn't be red, it would appear blue. Life on Earth will become impossible in about 1.1 billion years. When the Sun's brightness increases by roughly 11%, boiling all the oceans and burning the planet's surface with intense radiation. The Sun is one of the brightest stars in our stellar neighborhood. Within a radius of 17 light-years, there are about 50 star systems, and the Sun ranks 4th in brightness among them. Its true color is white, but it appears yellow because of the way its light is scattered and refracted by Earth's atmosphere. A single solar flare releases as much energy as 150 to 160 billion tons of TNT at humanity's current rate of energy consumption that would be enough to power civilization for about 1 billion years. It was only in 1990 that the Vatican officially acknowledged that the Earth revolves around the Sun. The Sun's mass makes up 99.86% of the total mass of the entire solar system. Surprisingly, the Sun contains far more water than Earth. In the form of water, vapor concentrated within sunspots and in a narrow layer just beneath the star's surface. A single droplet of the Sun, if somehow separated and reaching Earth, would cause an explosion comparable to a nuclear blast, wiping out everything within a 150-kilometer radius. The Sun's surface is not solid, it's plasma-like, made primarily of hydrogen and helium. Its radiation is deadly to all known forms of life. But Earth's atmosphere and magnetic field shield us from it, keeping our planet safe. The Sun is the only star in our solar system. Like any other star, the Sun has its own atmosphere, but unlike Earth's, its outer boundary extends far beyond Pluto's orbit. The flag planted on the Moon by American astronauts has long since faded completely white due to solar radiation. The Sun's characteristics are so immense that they are almost impossible to comprehend in familiar human terms. If we compare the relative sizes of the Sun and the Earth with the distance between them, we 1 millimeter about the Earth from the Sun. The color of our skin depends on the Sun, the angle at which its rays strike the Earth has influenced the human body's adaptation to external conditions throughout evolution. Humanity was able to come closer to understanding the mysteries of the stars, and particularly the Sun, only thanks to scientific progress. More than 90% of all solar researchers who have ever lived over the past 2,000 years worked in the 20th and 21st centuries. Schwab, a pharmacist and amateur astronomer, observed the Sun for 43 years in hopes of discovering a new planet. Instead, he discovered the 11-year cycle of solar activity. The energy stored in oil and other fossil fuels also originates from solar radiation in the distant past. This energy was captured through photosynthesis. Jupiter is the perfect planet for launching exploratory spacecraft. Because of the proximity to Earth, most probes would burn up en route. But Jupiter's strong gravity allows spacecraft to perform a special maneuver to get as close to the Sun as possible. The phenomenon of radioactivity was discovered in 1896 by the French physicist Antoine Henri Becquerel, who was studying the age of the Sun. At that time, Zarman, the object's used object. Since ancient times, people have been fascinated by space and distant stars. Yet, even the nearest celestial bodies remain only partially explored. We still don't know everything about the Moon, though some facts about it continue to amaze us. The Moon experiences extreme temperature fluctuations because of its thin atmosphere. At night, temperature can drop to -173 degrees Celsius, where there is 127 degrees Celsius. We always see only one side of the Moon because it rotates on its axis and orbits the Earth in the same amount of time. For a long time, scientists couldn't obtain data about the far side of the Moon. This was first accomplished in 1959 when the Soviet spacecraft Luna 3 took photographs of it. There is water on the Moon, discovered by Soviet researchers in 1978. At least 600 million tons of water exist there in the form of ice. During a total solar eclipse, the moon almost completely covers the sun. This perfect coincidence occurs because the moon is 400 times smaller than the sun, but also 400 times closer to the Earth. It's commonly believed that wolves howl at the moon, but is it true? Researchers have found no evidence linking their howling behavior to the full moon. The moon also experiences earthquakes, known as moonquakes. They are much weaker than those on Earth, and this seismic activity is caused by the gravitational influence of our planet. The moon is moving away from the Earth at an average rate of about 3 centimeters per year. Over billions of years, the distance between these two celestial bodies has increased nearly 20-fold. Originally, Earth's satellite was only about 22,000 kilometers away, but today it's almost 400,000 kilometers distant. In reality, the surface of the moon is quite dark, although it appears bright in our night sky. Its reflectivity is only slightly higher than that of asphalt. The moon's gravity is much weaker than Earth's, about 16.5% of Earth's gravity. This means a person would weigh only 16.5% of their Earth weight on the moon. So, if you've ever wanted to feel as light as a feather, welcome. You could also jump incredibly high there, almost like a superhero. But have you ever wondered about the moon's influence on Earth? What would happen if our satellite disappeared? First, tides would drastically change. The rise and fall of sea levels would occur at different intervals, and floods could begin to occur all over the planet. Second, Earth would start spinning faster on its axis, shortening the length of a day from 24 hours to about 22. Third, the disappearance of the moon would cause Earth's poles to shift and trigger significant climate changes. Is there life beyond Earth? This question has fascinated scientists around the world for decades. And according to research, the answer may be closer than it seems. So far, Earth remains the only known place that harbors life, but there could be many more planets capable of supporting it. Today, scientists around the globe are focusing their attention on studying super-Earths. A super-Earth, or superterrestrial planet, is a class of exoplanets with a mass greater than Earth's, yet much smaller than that of gas giants like Neptune. NASA continues to track the growing number of these discovered cosmic bodies. As of October 12, 2022, astronomers had confirmed the existence of over 5,000 exoplanets, with about 9,000 more listed as candidates. Exoplanets are planets that orbit stars outside our solar system. In the summer of 2022, NASA's telescopes identified several unusual exoplanets. One is 35% larger than Earth and completes an orbit around its star in less than 3 days. Another is about 5 times larger than Earth and may be covered entirely in water. According to astronomer Chris Impey, these planets have a real chance of being habitable, though finding them is easier than proving they host life. As astronomer Suba Zli noted, super-Earths are ideal targets in the search for life for 2 main reasons. Scientists have focused on planets orbiting the most common type of star in the Milky Way, red dwarfs, also known as M-type stars. These stars are smaller and cooler than the Sun, but incredibly long-lived. For every Sun-like star, there are hundreds of red dwarfs, and about 40% of them are orbited by super-Earths. Astronomers estimate that there could be tens of billions of super-Earths located in habitable zones, where liquid water may exist. Since water is essential for life on Earth, it is considered the key factor for habitability on other worlds as well. Super-Earths are difficult to detect and study because of their relatively small size. Astronomers rarely observe exoplanets directly through telescopes. Most of them are discovered using indirect detection methods. For example, NASA's Kepler Space Telescope has found thousands of planets by observing transits, moments when a planet passes in front of its star, causing a slight dimming of the star's light. This technique, known as the transit method, is one of the most effective ways to find distant worlds. Other detection methods include gravitational microlensing, the radial velocity method, and direct imaging. But why might super-Earths be habitable? For centuries, scientists and philosophers believed that Earth was the best possible world for life. One of the supporters of this idea was the German philosopher Gottfried Wilhelm Leibniz. However, with time, astrobiologists discovered that Earth has not always been perfectly suitable for life. The planet's climate has constantly changed due to tectonic activity and fluctuations in the sun's brightness. For most of its history, Earth was inhospitable to humans and complex organisms, yet life managed to adapt to extreme conditions. From freezing temperatures to radiation, this suggests that life on other planets could also have adapted to their unique environments. Scientists have even discovered an ocean planet beyond our solar system. So far, at least 20 super-Earths have been identified that are theoretically more suitable for life than Earth itself. But what makes a planet truly habitable? Ensuite, scientists have compiled a list of key characteristics such a world must possess. The planet must be geologically active, which supports biological evolution. It must have oceans. The average temperature 5°77 degrees. Its atmosphere must be thicker than Earth's, acting like an insulating blanket. The planet should orbit a star older than the Sun. It should have a strong magnetic field to protect against cosmic radiation. How will scientists search for life on super-Earths? The search for life on individual exoplanets is a long and promising process. Astronomers will study the atmospheres of these planets, looking for biosignatures, chemical or molecular traces of life. To help with this mission, NASA's James Webb Space Telescope JWST plays a crucial role. However, as astronomer Chris Impey noted, JWST was actually designed before the discovery of most exoplanets. Despite this, the telescope is perfectly equipped for detailed observations. It carries 3 main instruments to operating in the near-infrared range and 1 in the mid-infrared. Observing exoplanets has become one of JWST's important goals, allowing astronomers to demonstrate the telescope's capability to capture detailed atmospheric spectra and potentially detect the first real signs of life beyond Earth. Friends, don't forget to subscribe and hit that like button. Your support helps our stories reach more amazing people just like you, and you'll never miss a single new tale. Go ahead, join our growing story-loving family today.